remember returning to Miami in about 2016 and just remembering the smell from the Biscayne Bay. It was just horrible. And I saw in the news soon after that there were tritium leaks from the Turkey Point reactor, and they had detected tritium in the water. That's the first time I became aware of that link between tritium, toxic algae, and radiation from nuclear reactors.
FPL nuclear plant canals leaking into Biscayne Bay. Study confirms. A radioactive isotope linked to water from power plant cooling canals has been found in high levels in Biscayne Bay, confirming suspicions that Turkey Point's aging canals are leaking into the nearby national park. According to a study released Monday by Miami-Dade County Mayor Carlos Gimenez, water sampling in December and January found tritium levels up to 215 times higher than normal in ocean water.
The report doesn't address risks to the public or marine life, but tritium is typically monitored as a tracer of nuclear power plant leaks or spills.
The study comes 2 weeks after a Tallahassee judge ordered the utility and the state to clean up the nuclear plant's cooling canals after concluding that they had caused a massive underground saltwater plume to migrate west,
threatening a well field that supplies drinking water to the Florida Keys.
Yeah, so I decided to search for tritium and what that had to do with anything and where that came from. I just saw the article and it just seemed related. It didn't really make a connection to the fish kills or the toxic algae or anything like that, but I just started doing research into it. I realized, there's a link between what they call heavy water sometimes, and there's definitely a lot of other leaks going on, including Indian Point and many others. You need to start paying attention.
SciShow is supported by Brilliant.org, a problem-solving website that teaches you how to think like a scientist. Refreshing glass of cold water. And if you think I'm talking about H2O, then you're right. But I could have just been sipping on heavy water, or deuterium oxide, aka D2O, just as easily. Well, not just as easily, it's super expensive, and I would have had to buy it from a lab supply store, but you get my point. Deuterium is a form of hydrogen, or isotope, with a bonus neutron, which makes it twice as heavy as the regular hydrogen we all know and love. That's why when there's deuterium in water molecules, it's about 10% heavier, and we call it
heavy water. What would happen if you just drank a glass of heavy water?
Don't go filling up all your water bottles with pure deuterium oxide, because too much of it will almost definitely kill you. Rats and mice die when about a third of the water in their bodies has deuterium in it. Plants also aren't big fans and will stop growing. This toxicity is related to what's called the kinetic isotope effect. Basically, the extra mass of the isotope slows chemical reactions down, including all of the super important reactions that keep
you not dead.
It's not totally clear how much heavy water would do a person in, but experts estimate that anything more than 10% of your total water intake could start causing problems. So a sip is okay, but don't push it. Also, it's not going to help you at all, and it's going to cost extra money. I don't really know why you would do this.
Still, there is a form of heavy water you should definitely avoid, tritium oxide, or super heavy water. Instead of hydrogen or deuterium, it contains tritium, an isotope of hydrogen that has 2 neutrons and is radioactive. Drinking them is another story. There's some evidence that once inside the body, beta particles might even be better at causing cancer than the high-energy gamma rays that come from things like radium. But because tritiated water is used in nuclear reactors, the real concern is when those reactors leak or if there's an accident. So I'm not recommending you do this, but if you really want to test out some heavy water, just make sure we're talking about deuterium oxide, not tritium oxide.
So you don't want to be a dead person.
The judge also found the state failed to address the pollution by crafting a faulty management plan. This latest test, critics say, raised new questions about what they've long suspected, that canals that began running too hot and salty the summer after FPL overhauled 2 reactors to produce more power could also be polluting the bay. How much damage is that cooling canal system causing the bay is a question to be answered.
Next article.
Another fish kill strikes Biscayne Bay. This seems to be becoming an annual event. The dead fish started showing up on Wednesday, the white shock of their upturned bellies dotting the shoreline near Morningside Park in the Tatum Waterway. They stunk. By that afternoon, scientists and advocates say it was clear that Biscayne Bay was experiencing another significant fish die-off, likely caused by the same low oxygen and high pollution levels that caused the last major fish kill in August 2020. This is the worst fish kill we've seen since the 2020 event, said Rachel Silverstein, Miami's waterkeeper. Really ring to people as massive alarm bells that this bay is dying. This is what a dying waterway looks like. Early testing from Miami-Dade's Division of Environmental Resources Management, which counted more than 1,000 dead fish, said the culprit is the same as last time, low oxygen levels.
But because tritiated water is used in nuclear reactors, the real concern is when those reactors leak or if there's an accident. So I'm not recommending you do this, but if you really want to test out some heavy water, just make sure we're talking about deuterium oxide, not tritium oxide.
So you don't want to be a dead person.
Fish start to struggle when oxygen concentrations dip below 5 milligrams per liter, and measurements taken Thursday at the mouths of Little River in Biscayne Canal showed levels near zero. Residents also reported seeing fish near the surface of the water gasping for air and struggling, along with clumps of dead flounder, toadfish and pufferfish. Tritium at the bottom of the bay close to the canals ranged from more than 130 to 215 times higher, high enough to suggest a consistent flow from the sprawling cooling system. County staff concluded the findings are the most compelling evidence that canal water has spread into the bay. While the county's consent decree requires FPL to address the spread, staff said more study is needed to determine exactly what's going on and come up with a long-term remedy for cleaning up the canals. This story was originally published March 7, 2016, 9:08 p.m.
From 2016, when I got back and smelled the stink that everyone else was trying to ignore for some reason. Yeah, this has been happening every year since, and this is now today. And these so-called experts still don't know anything, right? They just have a bunch of unrelated theories to confuse you in the issue. They're either lying or they don't know what they're doing.
Well, the problem we have seen before is back again. Thousands of dead fish washing ashore in South Florida.
Several thousands of fish have been reported dead in the past few days in Dade County. The other areas affected include Bayfront Park, Miami Shores, parts of North Bay Village, and North Miami Beach.
Fish literally suffocating to death because there's little to no oxygen in pockets of the watershed caused by too much pollution flowing into the bay.
This is an indication that Biscayne Bay has crossed a tipping point. We're now starting to see annual fish kills in Biscayne Bay.
This one so far not as catastrophic as the unprecedented fish kill of August of 2020 when the bay lost more than 27,000 marine species. Still, already, Miami-Dade County's Department of Environmental Resources Management has received reports of over 1,000 dead fish since Wednesday morning.
This just tells me.
Now, this is actually looking at Hudson Bay, the banks of Hudson Bay in New York. Just to show you also that nobody's really paying attention. I mean, people are, but the people in charge, they're completely derelict and they're completely blind and stupid. This is Hudson Point. This is why. So don't take the excuse anymore that they don't know because they should. They don't, but they should. So from Miami and New York, let's go to Russia again. So this article here, it's interesting. I mean, this is from 2020, so this is very recent as well. It basically says this beach has unprecedented algae blooms and the decimation of bottom-dwelling sea life, and it has devastating ripple effects. And of course, it talks about the sea otters and all the other marine creatures that depend on those bottom species. Bottom feeders are the start of the food chain, right? Phytoplankton, for instance, and coral and all that stuff. This thing says, September 14th was a rare sunny day. A seaward wind was whipping, and at 54 degrees, the water was warmer than even the air. But conditions were ideal for surfing. Never mind that. Better start looking out for red tide and toxic algae and flesh-eating bacteria. Not to mention no more fresh fish, which people need, and less oxygen because your atmosphere is escaping and your phytoplankton is not producing any. So therefore you're only getting it from the trees now, which you're cutting down. Anyway, wake up or go back to sleep. Either way, stop trying to shame people for telling the truth just because you're afraid to or you're not smart enough to. Stop trying to shame people from telling the truth. And stop following influencers or people who are following TV who don't really know anything or never got good grades or can't tell you anything new. They just make you feel better about yourself. Stop following those people. Start aiming higher. Start trying to listen to people that know more than you instead of just trying to make yourself feel good all the time. Not talking about money. You know, people like this great man who should be celebrated but isn't, in a world of mediocre people celebrating mediocrity. You should start celebrating things that are great and people that are great, like this man.
Impact that our use of energy is having on the environment. Back in 2002-2003 time frame, the Nobel Prize laureate Richard Smalley did a study. He wanted to identify the top 10 problems that face humanity, and he ranked energy as number 1. And he justified that by explaining that by solving the energy problem, you'd be able to solve all of the other problems on the list. Ideally, we would transition to a different kind of energy source, such as electric vehicles. To put that into perspective, 80 million cars produced every year. The battery for the Tesla Model S cost about $50,000. So you're talking about an economic impact of about $4 trillion in batteries every year.
As a side note, I did the calculations myself from back in 2006, based on the war and all that stuff, the money they were spending on wars up to that point, like $1 trillion per war. And I calculated that $1 trillion could actually provide pretty much 5 kilowatts of energy to, at the time it was like 100 million homes. But now, because it's cheaper, it's actually 200 million homes. So 5 kilowatts of solar on 200 million homes. That covers all the homes in the US, Canada, Mexico, and even part of Central America for $1 trillion. Now he's saying $4 trillion for batteries alone, and it's $1 trillion just for each war minimum. right? I wrote that in an essay called The Mathematics of Morality. I tried to publish it, Miami Herald or wherever I could. I sent it everywhere, no takers. But it's a simple concept. Another concept is basically 1/10 of the Mojave Desert covered in solar could actually provide enough energy that the world needs, actually. So the way you would transport the energy is with hydrogen. You would actually electrolyze water, so you could pump seawater or wastewater in, electrolyze it, store the hydrogen, pump it out, transport it, tanker it, pipeline it out. And you would use that to run natural gas generators that basically run quiet, and they'd have to be kind of altered a little bit from how they operate now, but they would basically exhaust water vapor, and they would run quiet, and there would be no pollution, and you would actually be able to cover the entire energy need of the entire world with 1/10 the size of the Mojave Desert, about 5,000 square miles, which, by the way, is the smallest desert in the world for now.
That we need, don't have the experience of having done this, but we're going to do it anyway. What we need is determination to solve the problem.
When I was a kid, I used to watch, some of you might remember these robots from Lost in Space and the other one from Robbie the Robot. I used to watch these robots on TV. I wanted my own robot. So I decided to build myself a robot. It took me over a year to build him. Then after I got it completed, the problem I had was that nobody told me that the other robots that I was watching had people inside. But I didn't know any better than to try. Later on, this is one of my earlier patents. It's a technology or an invention that uses digital encoded scales that have been photographically reduced and a magnifying lens and a photosensor to read binary coded information from that scale. This is the base technology for CDs and DVDs. I got this patent back in 1979. I call it the big fish that got away. Well, I was having fun working on spacecraft. I was working on the Galileo project, which is presently in orbit around Jupiter. I have an invention on that spacecraft. I worked on Mars Observer, Voyager program, the Cassini mission to Saturn. So I was enjoying my day job.
As another side note, being an engineer, a great engineer for NASA, doesn't mean you necessarily know what NASA is up to or what's going on in space. I don't believe half of what NASA says, but I do know engineers that work at NASA. Actually, I know two, and they really don't know what's going on in the world. They just do their job, So the Saturn thing, I personally made a scientific discovery about Saturn, about the hexagon in Saturn, and I beat NASA to it, and they still haven't contacted me yet.
Eventually, I was working on a new type of heat pump. The idea here was to come up with a new type of engine, heat pump rather, that did not use Freon, because Freon's bad for the environment. I wanted to use water as a working fluid instead. As I was experimenting with this engine, this heat pump, I built some nozzles and I shot a stream of water across the bathroom, and I thought, geez, this would make a neat water gun. So I put the heat pump aside. I figured that if I could I was having trouble getting people to finance and support this hard science stuff that I wanted to do, so I figured if I got some money from a toy, something anybody could appreciate, then I could have the money to go off and do my own products. And so I did. And I do have a first prototype here. Now, people know me for the Super Soaker, but what they don't know is that I'm responsible for the success of the Nerf dart gun line as well. I assume you're all familiar with Nerf. Some of you. You're not? Needless to say, I've been able to move forward with my hard science stuff, and I'm going to talk to you about some of that today. I'm working on a new type of engine and a new battery that will address the environmental problems that I was talking about. One of the things that have happened along the way, I was anointed by Time magazine as one of the top inventors in the world, and my engine was actually identified as one of the top 10 world-changing innovations. So back to the problem. I felt I'm qualified to solve this problem, so I don't know any better, just like with the robot, I don't know any better than try. And this is my engine. It's called a JTEC. It converts heat directly into electricity, and if you look at it, I like this chart too as an engineer. We'd be able to use it to collect energy from the sun and produce electricity directly. And that electricity then, and produce it, by the way, more efficiently than solar cells, so that the cost of the electricity would be competitive with fossil fuels.